volumes via the EBS CSI driver. Then I configured the GP2 storage class. Then I also implemented the proper volume binding modes. Implemented the proper volume binding modes, and that's all about storage. So we're moving on to the monitoring. You see that here in the monitoring, I created this Kafka exporter. And what's the Kafka exporter meant for? It's used for metrics collection of data on this project. So I had to configure it to expose Prometheus metrics. To expose metrics on this Prometheus on port 9308. So let's move on to the CI/CD pipeline, and I will explain everything on this CI/CD pipeline. So the CI/CD pipeline, we have three pipeline workflows here, which is the Terraform plan workflow, we have the Terraform apply workflow, and we have the Kafka deploy workflow. So the Terraform plan workflow, I had to trigger pull request to the main branch. I have to trigger a pull request to the main branch. Then the purpose of this is to validate the infrastructure changes before merging. Then the steps that I carried out was I check out the code. I had to check out the code. Then I set up Terraform with version 1.90. Then I configured the AWS credentials using the OpenID Connect authentication. Then I had to also initialize Terraform with remote state backend. Then I validated the Terraform configuration and generated and display execution plan. So that's that about the Terraform plan workflow, and this is exactly everything I've listed here, and everything you can see on the screen is exactly what we actually put in place so that the workflow can work accurately with the project. So moving on to the Terraform apply workflow, then the Terraform apply workflow, I had to trigger and push to the main branch. I had to trigger after writing all these projects. Then I had to for Terraform apply workflow, the purpose of this Terraform apply workflow is to deploy infrastructure changes. And the steps that I carried out was to I checked out the code. Then I set up Terraform with version 1.9. Then I configured the AWS credentials with the OpenID Connect authentication. Then I initialized Terraform with remote state backend. And I also validated the Terraform configuration. Then I generated the execution plan. With this, I was able to apply the changes to provision and update the infrastructure. So these are everything that went on in the Terraform apply workflow pipeline. So the last one, which is the last pipeline for this project, is the Kafka deploy workflow. On this Kafka deploy workflow, then I had to trigger and successfully complete Terraform apply workflow. And the reason why I successfully completed this Terraform apply workflow was the purpose of this is to deploy Kafka resource to the provision EKS cluster, because that is the end goal. The end goal of this project is to deploy all the resources that we have actually put together, we have actually provisioned in the Terraform. We are expected to deploy everything to the EKS cluster, and the steps that were undergone in this pipeline was that I checked out the code. Then I set up Terraform. and configured AWS credentials using the OpenID Connect authentication still. And then I installed the kubectl, and I updated. After installing the kubectl, then I had to update the kubeconfig to connect to EKS cluster. On my screen, you can see that while you can see the processes on my GitHub, where also I had to wait for Kubernetes cluster to be ready before installing Streamz operator. Then while waiting for Streamz operator to be ready, I had to configure the storage classes. And during this process, then I applied the Kubernetes manifest. And if you see that in the Kubernetes manifest, we have the namespace, we have the storage, we have the Kafka cluster, and the monitoring. So all these were applied in the Kubernetes manifest. Then I had to wait for the Kafka cluster to be ready. Then So that was everything that or that were undergone. That was everything that were undergone in this project. So I've been able to walk you through this project, and I know that there are still other things that were undergone in this project. So I will just talk a little bit on the project. So I the application of this deployment, yeah, the application of this deployment is for Streamz operator. The Streamz operator was actually installed in the Kafka namespace. Yeah, the Streamz operator was installed in the Kafka namespace. Then, if you want to actually check after deploying everything to the AKS cluster, to for you to be able to get the resources under the Kafka, then you use the command kubectl get pods, then namespace Kafka. Yes, because the we have actually deployed the Streamz operator installed in the Kafka namespace. So you can get everything that has to do with the Kafka namespace. You can get everything that has to do with the Streamz operator is there, is all installed, and you can see it on your screen. So and also Kafka cluster was also deployed. Yeah, it was deployed using the Streamz custom resources, and the zookeeper is there. The monitoring components are all there and they are deployed. The monitoring components, they are all there and deployed on Kafka exporter. So and you as you can see, when I was talking about the security features of the IAM role, yeah, which was actually needed there, and the OpenIDC connect was actually needed. The network isolation, the private subnets for internal resources were there, and the encryption using the EBS volume were actually they are all these are encrypted by default. So the monitoring and observability tools, yeah, we made use of the Kafka exporter. Yeah, that I talked about Kafka exporter and how they were able to expose Kafka metrics in Prometheus format. And also, no, not forget that the health checks is also important in the whereby the Kubernetes liveliness and the readiness probes were also very included in this project. Then the logging, where we actually included the CloudWatch integration for infrastructure logs. You can actually see that on the after creating your EKS cluster, everything, all these are actually there, and they are they are actually displayed and well provisioned well on the Terraform on this Terraform project. So yeah, and also you see that we use the multi-AZ deployment. Yeah, the VPCs, the EKX expand across multiple availability zones. So and also I was able to replicate components using the Kafka brokers and the zookeepers, which run with three replicas. Yeah, it runs with three replicas, and you only understand the word replicas when you say replication of components. Yeah, if one component is down, the others are it's actually it automatically creates other replicas so as to not have a downtime with the project. And also, when we talk about auto healings too, Kubernetes automatically restarts. Like I said, yeah, it automatically restarts new components when one component fails. So this project is a production-ready Kafka deployment on AWS AKS, and it was automated with GitHub Actions, and we have a secured CI/CD pipelines and robust monitoring capabilities on this project. Thank you for listening, and my GitHub right there is right there in this project. So you can actually go there and give me a few stars if you actually enjoy the project. Thank you.